The main three axes: research, innovation, and...
So what you see here is the location of CERN, and the first thing you see, this is this huge ring, which is the Large Hadron Collider, which is the accelerator. It's a 27-kilometer ring, which is underground in a tunnel at 100-meter depth. So I'm going to cover the three aspects I said: research, innovation, education. And extremely important is also, we do all this by getting people together, unifying people. So the first thing, the first mission is to really understand the frontiers of the knowledge, to push forward the frontiers of the knowledge, to go to the real point, the secret of the Big Bang. What is the matter made of? So this is our fundamental research mission. But to do so, we have to go for really to be at the forefront of technology. So we are doing major developments in accelerators, detectors, also computing, I will mention briefly. And as I said, the third point is to train scientists and engineers for tomorrow. We put a lot of emphasis on it. And as I said, important is to bring people together. What you see here on this last photo is our yearly summer student event, which brings to CERN over 300 summer students from member states and non-member states. So CERN was founded in 1954. At that time, 12 member states. It was meant to be, and it was science for peace. Today the situation is we have 20 member states. You see the list of all the member states here. There is one candidate for accession, there is Romania. And we have now, since recently, because CERN somehow wants to get out from the European frame to a worldwide frame, we opened to a new status, which is the associate membership. And here we have Israel and Serbia. And on the list, you have these 7 countries: Brazil, Cyprus, Pakistan, Russia, Slovenia, Turkey, and Ukraine. And in addition, you have some observer states. Today, CERN has a total of 2,300 staff members, plus order of 1,300 students, fellows, etc. But the important thing is to notice the high number of users. These are people coming to CERN for a short period of time, contribute to the experiment, and then go back to the home institute to analyze data. What you see here is 1 billion. This is the total budget of CERN per year. So here you see the distribution of all these 11,000 users, and you see it by nationality. And in blue you have the member states. In red you have the non-member states. And here I have listed with a red star the Arabic countries. And if you sum up all the people contributing to the CERN, you have a total of 70. If you look by nationality, now if you look by location of the institute, you see it goes down to essentially only 3 countries, which is Morocco, Egypt, and Saudi Arabia. So the distribution, the age distribution of the scientists, you see it really nicely peaks to young people. The peak is at 26. And the important thing to notice is we give order of 2,500 PhD for the 4 LHC experiments. Now, quite often people ask, what are these PhD doing after their PhD? You see that quite a lot, they go to industry, and only probably 20% they go to research. And going to industry, most of them they go to computing, or some of them also to finance and communication. So back to the scientific challenge. Again, is really to understand what has happened at the time of the Big Bang, and how the universe how was the evolution of the universe. The evolution of the universe took 13.8 billion years, and from a point-like source at the time of the Big Bang Today, the dimension of the universe is 10 to the 28 centimeters, which is hard to visualize how it is. I can tell you it takes to the light to travel from one extreme to the other one 10 billion of years. So again, this dimension of 10 to the 28, you have it summarized here on this ruler. So this is the dimension of the universe. Some other references is the distance Earth to Sun, the radius of the Earth, and these are for the large dimensions. If you then move to small subatomic dimension, you have the atom, the proton, and then at the time of the Big Bang, probably dimension of the order of 10 to the minus 32. To explore the universe, we are using telescopes. Some of them are located on Earth. Some of them are embarked on satellites. Then going to more usual dimension, which is the human being. Here you have a nice picture of Einstein. We are made of matter, molecules, atoms, electrons, nucleus, this all you know, then protons and neutrons. And what we are now aiming at is to better understand, the behaviors of the quarks, which are the constituents of protons and neutrons. And to do so, we need an instrument which we call a super microscope. And this is the LHC, the Large Hadron Collider, in which we accelerate protons and we bring the protons into collisions to create matter. So as I said, this is in order to explore really what has happened at the time of the Big Bang or just after. And doing so, we somehow make complementary studies to what is done at larger scale. So again, to summarize, the four challenges. The first one is really to understand, the primordial state of matter. Then the famous Higgs bosons you probably have heard about, so we have discovered it. But now the next challenge is to understand what are the properties of the Higgs bosons. To understand why the matter and antimatter is not completely symmetric, why there is CP violation. And finally also to see what this famous dark matter is made of. And here we have some ideas, and this is called supersymmetry. So this is our fundamental challenge, our mission to really answer these questions. So what has happened with the LHC, the Large Hadron Collider? It has been put in operation, this was in March 2010, and is ready to explore a completely new domain, either in proton-proton collisions or in lead-lead collisions. So the particles are accelerated in this tunnel I have mentioned before, and the collisions, the product of the collisions, are detected by 4 experiments. The one is ATLAS and CMS. These are general purpose experiments. There is one called LHCb to look into CP violation. I have mentioned this is the asymmetry matter-antimatter. And ALICE experiment, which is to look into the quark-gluon plasma. So after this, there was on the 4th of July 2012, a big agitation at CERN and the press conference because, we had some hints that the Higgs boson was found. And indeed, you see this little signal here, and this little signal here was the signature of the discovery of the Higgs boson. And I cannot resist to show you a nice event of the ATLAS experiment. So you here at the center of the detector, you have the collision. There is a Higgs produced, and then the Higgs decays into 4 particles, which in this case are electrons. And the electrons are detected inside what we call the calorimeters, and the energy is reconstructed. So this has given then a lot of agitation at also at the level of the media, which you see here. but also, I mean, in the scientific world, I mean, we have made our publications. There are many, many papers going out. And in addition, and this you probably all know, that, I mean, it has given, in October 2013, the Nobel Prize to Mr. Engler and Higgs, who had this idea of the Higgs boson. But it's also stressed that this was made with the help of the ATLAS and CMS experiments and the contribution of the CERN Large Hadron Collider. So we somehow feel part of this Nobel Prize. So this is my only slide about computing. This is really a snapshot that you see from one daily operation at CERN, and you have hard time to read over there the number of running jobs at that time. It was 150,000 jobs running at a given time, and it's the bandwidth is order of, you cannot read it here, it's in hundreds of gigabytes. So we have connected 48 countries in a total of close to 300 sites, and is 250,000 of CPU cores, and the total disk storage is 100 petabyte, and order of 1 million jobs per day. So I mean, our community, the high energy physics community, is making use of the grid facility, but it's not the only one. Many others are making use of the grid. So now I move to innovation. So innovation, we clearly need to be always, as I said, at the forefront of any technical development, be in the area of the accelerators or in the area of particle detection, or in the domain of computing. And also then there is some connection between the expertise there is in such a laboratory, which you see, and this you see looking at this matrix here, which shows you the matrix between technology domains that we have some expertise at CERN, and application fields in different domains. And you see that clearly, I mean, in the area of medical application, there is a big come back to the discipline. Sorry. So about medical application, another way to illustrate the thing is to show you this, which is that since quite some years now, more and more one is using hadron therapy to fight cancer instead of using X-rays. And you see that worldwide we have actually 30,000 accelerators, out of which 17,000 are used for medicine, used to treat order of 70,000 patients all over the world. So this is one of the spin-offs of particle physics. The second spin-off is about imaging. So here we use the techniques that we have developed at the level of our particle detectors, in particular detecting photons, and this is used in the positron electron tomograph scanner. So this is a direct consequence of what we are doing in fundamental science. Here also I wanted to mention one of our collaboration in the area of accelerators, and this you certainly have heard is about the Sesame project. This is a project based in Jordan, and here you have the participants. And we have recently, so it's a first major international research center in the Middle East, and somehow CERN serves as a model in the sense that, I mean, it's meant to be a lab science for peace. And as I said, the expertise we have at CERN about accelerators, we are sharing now with Sesame. And the plan here is to get this installation started in 2015. Let me go back to CERN and to the educational activities. Here we're doing a huge effort in order to essentially make the effort on young researchers. We have many schools on high energy physics, on computing and accelerator. The schools, they take place in various places. There is, for example, one in Brazil, there's one in Japan, there is one in Hungary. So this is for the young researcher. Important is also all the programs we have for the teachers. Here people, they come to CERN for teachers, they come to CERN for 1 week. They are taught about heavy ion, high energy physics. And then, as I have mentioned a bit earlier, is the physics students program. Every year we get 300 students to CERN. So this is again distribution of the worldwide for the teacher program over this period of 15 years. Again, here I have focused on the Arabic countries, so you're not that many. So clearly here, that's something we have to improve a lot. Situation looks better if you look at the students, the summer students. You see over the years 2009 to 2013, we had a total of 55 students from the Arabic countries at CERN. So now Middle East, North Africa and CERN collaboration. So CERN is open to collaborate with any interested scientist from any country. So far we have cooperation agreements signed between CERN and Algeria, Egypt, Jordan, Morocco, Saudi Arabia. Tunisia, we are almost there. We're in the process of preparing the signature, and the Emirates. And then there are contacts with many individual scientists from many other countries, Lebanon, Palestine, Qatar, and Tunisia. As I said, the training program is open to any country, be it the physics, engineering, information technology, or for the summer students and the high school teachers. Then there is open access to scientific information. So this is all about digital libraries. And here there was a meeting, CERN, UNESCO, School on Digital Libraries, which was in Rabat in 2010. And there is also some collaboration with Tunisia using CERN technologies in database handling. About exhibition, we are discussing possible exhibitions about particle physics in Egypt, Morocco, and Tunisia, la Cité des Sciences here in Tunis. And also UNESCO is offering some support. In a nutshell, over the Middle East and North Africa area, all the kind of relations between CERN and the countries. Here you see the cooperation agreements I have mentioned, other scientific contact, the teacher and the summer student. So you see it's quite well covered. We certainly can do much, much better. And that's probably all I have. Yeah, that's all I have. Thank you.
Thank you very much. Do we have some minutes for questions or not? 5 minutes. Please, if you have any question for any of these speakers, please do not hesitate. Any question? Yes, please.
A question about, I know you generate quite a lot of data. You're probably the most in the world. How do you handle transferring that data? How do you handle the storage and transferring of the huge amount of data that you have? Can you give us an idea, some stats maybe? Give it a second, it'll sync.
This one is fine. So the way the things are organized is in different layers, what we call tiers. There is a tier 0 at CERN. Then you have tier 1 centers distributed all over the world, and then you have tier 2 centers. So the data are produced at CERN by the experiments. They are processed locally, but then they are sent to the tier 1s and redistributed to the tier 2s to be final processed. And then the physics data, they come back to CERN. This is how it's organized. So this is all based on the grid structure.
Yeah, but how it is sent? What's the bandwidth that you are using? What are the connections between the various tiers? So you mentioned that you have approximately 1 pico or terabit of data produced on a daily basis, if I'm not mistaken. So how do you transfer this data? What's the backbone behind it?
What we are using is the grid infrastructure, and this is a géant behind. Is géant behind, yeah.
Other question, please? Yeah.
I have a question on the Silk link that you have mentioned, the STM1 155 megabits per second that goes from Afghanistan to Vienna. I'm interested to know the costing and the route that comes from Afghanistan. This is number one. Number two, we're thinking about because the Arab region spans all over Northern Africa region, Middle East, and the Gulf region, so Iraq and to the west. So do you see an opportunity, for instance, if there is some kind of a hub in the northern part of Iraq that can make the traffic that comes from Afghanistan, from maybe Kazakhstan, all the northern part of the area, that can come to the hub and then probably across some terrestrial cable, or maybe Russia, Qazvin, and Black Sea that goes all the way to Europe. So I'm just curious from your experience, what is because so far we have been, there has been so much demand that comes from the Fujairah, the sea and Red Sea, and that goes to Mediterranean countries and all the way to Europe. And there has been so many cables that are laid down in that region. I'm very much interested to know more about terrestrial cables that pass in the northern part of our region. Thank you.
The STM-1 goes through Pakistan and from Karachi through underwater to Marseille, and from Marseille to Vienna. We chose after discussions with Jean, we chose Vienna as the point to interconnect, because at that time it would have been not been possible yet to connect at Marseille, which would have made sense since the cable landed there, because there was not a real GEON hub there, but only a way to pass things forward to an existing GEON hub. But for future connections to GEON, I understand there would be also the possibility to use Marseille, because it's such a nice landing point. I see you nodding. Okay. Regarding the Asian connections, of course, Afghanistan has connections to various neighbors. In the west to Iran, in the north to Turkmenistan, that's in the works, because the internal fiber network of Afghanistan is built like a ring. There is more or less a big ring road in Afghanistan, and that's the form also of the still in the installation phase being a ring of fiber. And there is a difficult place in the northwest, and so there is a detour through Turkmenistan, so that's one way out there. Then there is Tajikistan, where is the connection, and it remains to be seen what will happen with China, which is on the other side, at the end of this very tiny valley. But that's in the future. So currently, things run through Tajikistan and through Pakistan. Um, Iraq is an interesting question. I don't have an answer ready on that. It would be interesting to discuss this further, but I don't think I can give you a reply right now. But distances in all these discussions are sometimes negative and sometimes positive. So geography is important to keep in mind, but sometimes the way around is the easier. So we'll have to look at that. I'll be very interested to discuss this with you.
Thank you. Any other question, please? Yeah.
Thank you. For Patrick, in the OpenStack community, we had some interesting news about cloud implementation in CERN. Can you tell us, I don't know how much you are aware, can you tell us from inside the story?
Here I don't have all the information, and certainly less than probably what you have. I know that at the level of the experiments, some tests were made, but that's really all I know. Unfortunately, I cannot tell you more.
Thank you. If there is no other questions, I will maybe a very small question, provocative question to Magda. She is not with us. Please, you have presented the different meetings and different recommendations to improve the Arab educations since 2005, 2007, and everything. But you didn't tell where we are now and what is accomplished.
Well, we must have hope. This is to start with. And I think there has been a big improvement. I mean, we hear about things that we didn't hear about a few years ago. I mean, training of teachers, prizes for good teachers, how to ameliorate the teachers' level, education for all is becoming, the role of families in the school is also growing. So there has been a movement in the region, and this movement has been very, I think, has brought up a lot of negativity, of course, but has brought up a lot of social work that is helping the official institutions to become better. Many of the families help the schools now because the governments don't have the means, because they know more than the teachers sometimes. So you see improvement. And it's no more blocked, all right? No, I'm very optimistic about the coming few years. And I see on TV young geniuses coming up from different Arab countries, especially with the iPads and the tablets. Now they have tablets in most of the schools. There has been a boom, I would say.
Okay, thank you. I hope that in the future years, in the near future,
I hope it continues.
we'll find some universities in the ranking of the international ranking.
That's
so
another issue.
Still there is not.
I hope so too. I hope
Thank
so
you.
too. Thank you.
So I have a question for Hedi Haddada. I was very interested to hear about CNRS. I think even those of us who have heard of CNRS, I was very surprised at the sheer scale of your activities, and I know from the fact that you're considering a regional office in Tunisia, that there must be an awful lot of work going on in North Africa and the Middle Eastern area. I was just wondering how much interaction do you currently have and how much involvement with the ASRENs in the region?
The structure that they have showed, it's very, very recent, and we are still in the preliminary contacts with the organs and structure in this region. So what I have mentioned is about the CNRS and his relations, but about this new structure, it's not yet. But what we have now is we have a project to evaluate the capability of the different countries to help the young scientists to build their own innovative companies and to help them about the patents, about to find finance. So we are still in the real beginning. We have started in March 2013.
But amongst the existing international cooperation activities of CNRS, I mean, have NRENs become involved in international corporations to date?
With the CNRS, you said?
Yes, with CNRS.
How many countries are involved in
No,
this?
I mean, I'm just interested to understand